So this lesson's about the types of chemical reactions and being able to identify the types of chemical reactions. Once we look at some chemical reactions, we start to notice that there's some patterns that show up in these, and there's different ways of naming those patterns, and that's what we're going to be going through in this lesson. So when you're trying to remember the types of chemical reactions, there's kind of a mnemonic that you can remember. Is squids don't carry roses, smile, or dance nicely. They don't do any of those things very nicely, or even at all. I don't know if they can carry roses. But the types of chemical reactions are synthesis, decomposition, combustion, replacement, and there's two different types of replacement. One's single and one is double. We are going to be talking mostly about single in this video and not so much on double, and we will cover double a little bit more through our neutralization reaction. The thing with double replacement is that it involves a lot of polyatomic ions, and we haven't covered those, and we're not going to cover those. But if that's something that you're interested in, you can do some research on it and learn about double replacement reactions as long as you were okay with learning about polyatomic ions. But that's a lesson for another day. So neutralization reaction is the type of reaction that we're going to look at in this lesson here. So ways of recognizing these types of reactions, we've got synthesis and decomposition, and we can kind of use what those words mean to help us remember what types of reactions we've got here. And if you think about if you're synthesizing something, I'm taking different parts and putting them together. If I'm going to synthesize a paper, I'm taking different ideas and putting them together to make one paper. And so our synthesis reaction is going to have a pattern that looks like this. A plus B, two separate things combined together to make one new thing, or combined together to make C here. And so that's the same way in our reaction down here. We've got sodium and chlorine, two separate compounds combined together through our arrow here, through our reaction, to form NaCl, sodium chloride. This is a completely new compound. Even though it's made up of sodium and chlorine, if you know anything about the properties of those things, sodium chloride is something that we need to survive, and sodium and chlorine are both dangerous. And so it's a completely new compound. We have synthesized something new. So we've got two things combining to make one. It could be three things combined to make one, but it's basically things are different compounds are combining to make this. And if we think about what it means to decompose something, decomposition, this is like breaking things down. And that's how I want you to remember this in this phrase here, is decomposition means to break things down. I take something and it breaks down into two or more different compounds or different things or different substances, right? If I'm decomposing something, I'm breaking it down into what it's made up of. And so if you look at our example reaction here, I've got mercury oxide, HGO here, and I'm breaking it down through my chemical reaction here into mercury and oxygen, two separate substances. And so I took one thing and I made two things, and that's kind of how I remember it, is how many things do you have on one side versus how many things do you have on the other side. But if you remember what decompose means, you should be able to remember what this reaction looks like. Those are the patterns on this one. You can also have a single replacement reaction. And so in order to show this one, when I think about replace, that means I'm replacing something with something else. And so I have in here, I have zinc, which is the only element right here. It's kind of formed by itself. It's just solid zinc. But then I also have two elements that have came together to form a compound. I've got hydrogen and I've got chlorine. Right? Two separate elements that are bonded together to make a compound here. And if I look over on the other side, I can track what I have for my elements. I've got zinc over here, but now zinc is bonded with my chlorine. Right? Two separate elements bonded together to make one compound. And if I look at my hydrogen here, which was blue in the last one, now hydrogen is all by itself on its own. It's not bonded with anything. It's actually bonded to itself in this gas here. And so what we had was our zinc came in and replaced the hydrogen in this compound with our chlorine. Right now our hydrogen is all by itself. And the reason why it's called single replacement is because one of them starts off all by itself. We have one element replacing one other element here. And so I guess the formula that I would share here is A plus BC, two compounds together, goes to AC plus B is the pattern for our single replacement here. And it doesn't just have to be A replacing B. A could have replaced C in this case, and I ended up with BA. It doesn't really matter which way, but one element is replacing another element in the compound, and that other one is kicked off and is now by itself. But this is what a single replacement reaction looks like. So another type of reaction is called a neutralization reaction, and you've heard the word acids and bases before, but this is a reaction between an acid and a base. And for our purposes here, we're going to focus mostly on strong acids and strong bases. And so some ways that you can recognize whether or not you're dealing with a neutralization reaction in a strong acid or a strong base is when you have like HCl is a strong acid, when you have HBr is a strong acid, and when you have HI, that's a strong acid. And those are some ones that we're going to be looking at in this class and in this unit are these strong acids. So these are ones you can write down, take notes on, memorize if you want to. You can remember that there's an H out in front of it, and then you've also got some sort of a halogen paired up with that and bonded to that, and that would be a strong acid. You also have our bases. You're going to be looking for this OH group, and this is called a hydroxide. Apologize for my handwriting. This is called a hydroxide ion. And when you see this OH bonded with another element like LiOH, that's a base. When you have our NaOH, that's also a base. When you have potassium hydroxide, KOH, and those are all bonded together, that's a base. When you have calcium OH, and two of those OHs, that's a strong base. And so these are the four that we're mostly going to focus on in this video and in this unit. But whenever you have one of these two reacting with each other, an acid and a base, you have a neutralization reaction. And whenever you have this, you end up having a salt and water being formed. And this is an example of what I'll call it as a double replacement reaction. When our H on our acid switches places with our positive ion in our base, our Na. And you can see how that works out over here. We end up having our H with our OH, forming water, H2O. And then we have our Na, our positive ion, right here, that switches over and now bonds with our negative ion and forms a salt, NaCl. And so this is an example of a neutralization reaction. What you should look for is an acid, one of these strong acids that I laid out right here, reacting with a strong base over here, and it'll form a salt and water. And that's an example of a double replacement reaction. It's the same type of mechanism here. So the last type of reaction that we're going to look at is called a combustion reaction. And the word combust means to start or burn or burst into flames. And so whenever we think about this and trying to identify a combustion reaction, I like to think about a fire. And we know about fires is that they need fuel, they need something to burn, and they also need air. If we snuff out a fire and we don't give it any air, it's going to die out. So we know that we need fuel plus air, specifically the oxygen in the air. And we know that these fires are going to actually give off water, which is kind of weird because you'd think that water would hurt a fire, but these combustion reactions actually give off H2O, and then oftentimes you're going to see CO2 in these reactions. And you're always going to see some type of fuel being combined with oxygen on our reactant side, and you're always for sure going to see my H2O, my water being given off. And often you will see this carbon dioxide being given off. Now the parts that might look a little bit different every time is what this fuel is, because we can burn a lot of different things. We can burn things like propane, hexane, we can burn butane, we can burn ethane, ethanol. We can burn a lot of different things. So our fuel could change, but we're always going to need oxygen. We're always going to get water and carbon dioxide out, mostly carbon dioxide. So you can look at this example right here that I have below, and this plus, this third plus or second plus, should really be an arrow. This is an arrow for our chemical reaction. That's not a plus. We have H2 gas and oxygen gas. So we've got our fuel and our oxygen combining together to form H2O. This is an example of a combustion reaction. We're burning hydrogen gas. If we look down below here, we've got our fuel, C3H8. Another way that you can look for is look for a lot of carbons and hydrogens. This is our fuel. We've got our oxygen, combining with our fuel, and we are producing carbon dioxide and H2O. And so you can see those compounds there. Now our numbers of those, or our amounts of those, change depending on what our fuel is, but we're always going to have that carbon dioxide in the water. And again, most of the time you're going to have carbon dioxide that you're going to see. And there might be some other things that are given off, but as long as you see fuel plus oxygen and giving off for sure water, sometimes carbon dioxide, you're going to be sitting pretty good at recognizing combustion reaction. And so that's the last type of reaction that we're going to talk about. We've got our synthesis and our decomposition. Either we're building something up or tearing something down. We've got our single replacement, where one element is replacing another in a compound. We've got our neutralization reaction, which is between an acid and a base. And then we've got our combustion reaction, where we're burning something. We need to have our fuel and oxygen in our reactant side of that. So I hope that helps you to identify the types of chemical reactions.